Chapter 5, past year, question 21. So in these questions here, you are given a function fx, which is a quadratic function, with the condition x must be greater equal to 0. Then in part A, they ask us to do two things. First, find the inverse of function f, and hence, if I have a composite function fg in such form, show that the gx is e to the power of 3x minus 1. So how we happen to solve for this question here? So first, we need to find out the inverse. Then you see the word hence. Hence here means that I must apply the inverse that I find to help me to show gx is equal to e power of 3x minus 1. And how we're going to do that? Let us first find out what is the inverse. And in these questions here, whenever you have the situation that you need to find out the inverse for a quadratic case, please take notes, guys and girls. It's very important that you must make sure your quadratics happen to be in the form of something like this. If it's not in this form here, then we need to apply completing the square. And obviously, we are in the form that we want, something like this, where we have our fx is equals to 1 over 5 x squared plus 1 over 5, where you can see the capital A corresponding to 1 over 5, the h is corresponding to 0, the k is 1 over 5. If it doesn't in this form here, let's say in general form, for example, in the form of ax squared plus bx plus c. Again, a more specific numerical example like this. Then what you need to do is that you need to, by applying completing the square, to reach this form here. Okay. However, the idea to use completing the square to get the form is not required here, as we already have the form we need. We just proceed for doing the calculations to find the inverse. Okay. So based on the question, we have fx equals to x squared plus 1 over 5, where the condition x is greater equals to 0. And when the time, if let's say I want to find inverse, in here, I will not use the methods of let y. And if you want to use the methods of let y, make sure in your calculation, you do have mentioned what is related with the inverse. If not, your solution is totally out. For further info, you may refer to the lecture notes. Okay. Anyway, continue with our solution. I'm going to use the idea of the properties of inverse in such that when the time I have composite of f and f inverse, then the answer is equals to x. And before we go on even further, just for you to take notes, how come it's equal to x? Is because it's based on whatever that I have inside the bracket here, then this is the result. If inside this bracket here I have y, so the result will equals to y. The idea is just as simple as that. Please take notes. And also may give you some misunderstood that you thought, oh, this thing cancel, that's why it's x. Oh, please, again, it's not cancellation. Okay, go on. So before we go on further, I need you to realize in the calculations of finding inverse from a quadratic function, it's always important to realize there is a conditions that you need to take notes. Where in here, the condition is f inverse is greater equal to 0. And how I get these conditions here? So guys and girls, please observe carefully and listen carefully. First of all, what we know about the idea of composite is that this is actually as if like I have function f, I want to substitute n inverse in it. So in other words, those part that now I highlighted come with x is the part that I'm going to substitute with f inverse. I'm going to erase and substitute with f inverse. So do the conditions. Where when the time I have fx, the x is come with the condition of greater equal to 0. So when the time I have the case of inside the bracket of f here is inverse, therefore I will have the inverse with the condition greater equal to 0. And this condition here is very important to take notes to help us to decide the correct answer of your inverse. Go on. So as I said just now, the composite idea is just that we substitute inverse inside the position come with x. So this is the result I have. when the time I substitute the x with inverse. And make sure you write properly, bracket the whole inverse, and then you square. Then next what we're going to do is that we try to rearrange the equation to find out what is our f inverse. And therefore, first I multiply both sides with 5 because I want to get rid of the denominator 5. Then I want to get rid of this plus 1 here. So I minus 1 on both sides. Then next, from square, I want to get rid of square. By right, I should have the answer of plus minus square root. Please be aware. From square, you want to get rid of square. By right, you have plus minus answer. Again, let's say I have y squared is equal to hashtag. By right, when the time I want to get rid of the square become y, I should have plus minus square roots of hashtag. And this is the idea I'm supposed to have. And in here, you see there is two possible answer for inverse, and which is the one that possible as our final choice. Of course, we are not going to take two of them, both of them, not both of them. Inverse only have one function, but which one is it? And then it comes the row of this thing here, the condition we mentioned just now. And if you notice, this is actually refer to the range of the inverse function for f. And if you refer to both of these functions here, you find out that the one that happen to fulfill this condition for its range, which is greater equal to 0, will be the case that I have positive square root. And therefore, there comes the conclusion for the answer. By the way, for those of you that happens to without have proper understanding of this idea here, maybe you can still get the answer where you just consider a misconception idea where you consider from square become without square, it just happen to have square root answer. Then that's the answer you get. And coincidentally, most of the time, it happened to work in this way here. But this is not a proper concept. And in this question here, if let's say it's tricky to you, the inverse, the request is happen to be less than equal to 0, then obviously this is the wrong answer. And just for extra info, if the inverse is referred to less than equal to 0, then my inverse will refer for the case of negative square root. Just in case, if let's say this is the condition we're referring. Okay. Anyway, these are not the condition required in the question, just for extra knowledge. And now we end our solution to find the inverse. Okay, go on. Then once we find the inverse, how we happen to find out what is the answer for the next part where we want to show the gx equals to the function required. As we can see in the question, again, we return to the question, we find the inverse. Now I want to solve the hence part here where my final answer is that I want to get the gx as this form here based on the composite function of fg. And how am I going to achieve this thing here? So let's see. So based on the info, we happen to know that my fg is given by this function here. And in here, you realize that I have one condition here where g is greater equal to 0, which this statement here is not stated in the question. And how I happen to get it? Because again, you refer back to the questions on top. If you have fx, x inside, so condition is x greater equal to 0. And now what I have is that I have fg, g inside, so condition is g greater equal to 0. And again, this will be very helpful later in order to determine the answer. Okay, then go on. Let's see how we happen to continue to solve this question. So observe carefully the things that I want to present it to you is that I'm going to first, I want to make use of the idea of the composite of inverse for f and f. So if I composite f and f inverse in this form here, we f inverse come first followed by f, then what is the result is that, so it depends what is inside the bracket here. If hashtag, then answer is happen to be hashtag. So this is the idea that I would like to make use of here. And therefore, you see I start my solution in this case here where I will have F inverse composite with G. Sorry, F inverse composite with FG. And why I want to do this is because, again, what is the objective of this question here? Find out what is the function of G from this composite function. If I want to find out the function G from this composite function, I want to do something to get rid of the F. One of the way I can do is that making use of the idea of the composite the composite of inverse. So this is come from the properties of inverse. So this is what I would like to apply. And by the time I write this thing here, before I refer to the result on the bracket become gx, there is another way that I can interpret this thing here, where this composite can be also interpreted in such that, if you observe carefully, I substitute the function fg into the f inverse. So now I want you to be aware, the left-hand side and right-hand side, I'm going to use a different ideology to proceed with the substitution and continue to do my calculation. So on the left-hand side, by the properties of inverse that I happen to have here, so I will get answer as gx because f inverse composite with f, the result will depends what is inside the bracket of the composite pair, like here. Tengok apa dalam, kalau hashtag di sini, the function is fx, so sorry, the function is gx, so it's gx. On the other side, please observe carefully. What happened on the other side is that I would like to substitute function fg into the f inverse. Therefore, this is what I have. Take notes, f inverse, we find out is 5x minus 1. So if substitute fg inside, that means the x, I erase it, become fg now. And then I proceed substitute my function of fg, and I realize what I have here is that I want 5 times of fg. Fg is 1 over 5 times exponent plus 1. So if I want 5 times of it, what happened is that I just have the exponent term. Where again, observe carefully, this is happened when the time I multiply with 5, because I have multiplied 5 here. Continue, I simplify the answer. I find out I have square root of e power of 2, 3x minus 1, and it gives me the answer as gx equals to modulus e power of 3x minus 1. And again, please don't think that the idea is just as simple as cancel square root of and also square like this. If I have square root outside of the square term, I cannot just cancel and say equals to x, but I need to back to the another definition on modulus. If you still remember, another definition of modulus is this one. Square root of square is actually equals to modulus. And if let's say you can't see how can it relate with modulus, maybe I rewrite in more step. This is actually square root of e to the power of 3x minus 1, the whole thing square. When you expand the square, you expand the power, this is what you have. Now you shall see this is how the idea I get the modulus. And by right, in modulus, in the world of modulus, we notice that we have two possible answers. One of them is happen to be positive y, the other one is negative y. And in this case here, we happen to choose the case of positive exponent, which means that I choose the positive y. The reason is because, back to the idea of the condition here, my gx must be something that greater or equal to 0. And in order to have that, this is the answer I suppose I have. Therefore, this is the solution we have for question 21. Question 21 for the part A.